in letter D, it asks us to determine the horizontal intercepts and interpret in the context of this situation. So here, I know that I can find, again, if I remember, and say, okay, my x and my y, my horizontal intercepts, they're going to be where my function crosses the x-axis, therefore y is equal to 0. So if I put my output equal to 0 for this equation and solve for x, then I would have something looking like this. Now, if I multiply both sides by x to get rid of x in my denominator here, now I just have 0 is equal to 254x plus 45,500. So really, when you solve for the horizontal intercepts, you're just setting the numerator equal to 0 and solving for that. When I solve for x, I'll subtract 45,500 from both sides. And then I'll get minus 45,500 is equal to 254x. And then divide both sides by 254. And then I get x is equal to negative 179.31. So here, what does that mean? Well, that would be negative lawnmowers produced, and so that would really have no meaning in the context of this situation. So we found the horizontal intercept, found that it didn't have really any meaning in this situation, so we can move on. Let's look at letter E. For letter E, it says, what is the horizontal asymptote, and determine the meaning of the horizontal asymptote for this problem. Well, to find the horizontal asymptote, we look at when x gets really large or really small, what is happening to the graph. And so if we look at this and say, okay, x is getting really, really big, we're not going to worry about really small because that doesn't mean anything in our problem here. But when x gets really, really big, what's going to happen? Well, the 45,500 really doesn't come into play when we're talking about x getting really, really big. So what we have is we have 254x over x, and then my x's divide out. So what I really have is y is equal to 254, and that is going to be my horizontal asymptote. I can confirm this on the graph on my calculator, and I like to use the table. So I go into table set right here, second window, and I'm going to have my table start at 0, and I think I'm going to go up in increments of 1,000. And then I'm going to look at my table, so it's second graph to get over to your table here. And of course at 0 it's an error because we can't divide by 0. And as I go up here, it looks like my values, my output is becoming closer and closer to that 254. And if I keep going down here, I can see it's getting closer and closer to 254. So that confirms that as my graph is going out, I have, and I'll get rid of this 750, we don't need that anymore, that my graph is approaching 254. And so what would be the meaning of the horizontal asymptote in this situation? Well, as I produce more and more lawnmowers, the setup, or my 45,500 that I needed to kind of get things going, my setup becomes kind of negligible. Therefore, the average cost of the lawnmower is just the cost to produce each unit. Let's look at the domain and range for this function. If we were just going to look at the domain and range, and if this was not in context, then so I'm going to say not in context. Then the domain would be all real numbers, but x could not equal 0. But since we want the practical domain, that means we want it in context. Well, we wouldn't have negative lawnmowers, okay? So we could have it greater than 0. Now there would be, we wouldn't go to infinity, but depending on your company, if you're Ma and Pop making lawnmowers or you're John Deere, then that could be anywhere from a few units to hundreds of thousands of units. So if we put x is greater than 0, I think that would be good for now. And you would, kind of back up your reasoning there, kind of give a reason for that. Now, the practical range, remember that our graph, it looks something like this. We have a horizontal asymptote at y equals 254. And so we're not going to fall below that. So for our practical range, our output, or since we used cost with respect to our units, would have to be greater than 254. Let's take a look at what this graph looks like now. Okay, to make the graph, sometimes I think the hardest thing is to set up your increments. What values am I going to put over here and down here? The first thing we need to figure out is what is my x value representing and what is my y value representing. And we know that this is number of lawnmowers. And then on my y, or my vertical axis, it is the average cost of the lawnmower. Let's see, average cost, I'll put of lawnmower. And you kind of have to play around with your increments. At first I thought I was going to have each one be 125, and then I thought, oh, that's a little odd. I'll just have each one be 100, and so each little tick mark be 100, and I'm just going to every other one put 200, 400, 600, 800, 1,000. And then on my number of lawnmowers, I made every little tick mark worth 50, so I'll just put it in increments of 100 here. And so that's what I have. I know that I have a horizontal asymptote over here at y equals 254, so I can, it looks a little low. Hard to have a ruler on the screen though. Okay, and then I need some values to put up here, and I think the easiest thing to do is again go back and use your calculator, utilize it, and go up to table set, and I'm going to have my table start at 0, and then I'm going to go up by increments of 100. Then I'm going to go to my table, and so when it's 0, of course there's an error because it's undefined, and then when x is equal to 100, my output is 709. So I want to come up here to 10709. That's going to be about there. And then I can just fill in my table with the outputs, or fill in my graph with the outputs that I got from my table. And 405 at 300, there's 400, about maybe about there. At 400, I have 367. So here's 367, maybe about there. 500, 345. And then I would just want to draw as nice, smooth curve as I can, getting my data in there. And so my function would look something like this. So hopefully that helps you see how we use rational functions and gives you a good idea about how to approach your assignment.